The next type of reaction we're going to discuss is an acid-catalyzed hydration reaction. This is very similar to a hydrohalogenation reaction, except that we're adding water across a pi bond instead of a halogen and a hydrogen atom. That's why we call this a hydration, because we're adding water. So if we take our standard electrophilic addition reaction, remember adding XY across this pi bond. For an acid-catalyzed hydration, we're adding H and OH. We're adding water across. This requires an acid catalyst. So in this case, the acid here is dilute. And this acid also needs to be non-nucleophilic. So if we used HCl, for example, we would just get a hydrohalogenation reaction. We need a non-nucleophilic acid, something like sulfuric acid or phosphoric acid. So how does this reaction work? Well, we're going to assume first that this water here is protonated by the sulfuric acid to generate a hydronium ion. The nucleophilic pi bond will be drawn towards the electrophilic hydrogen here, which will then kick off this water molecule and eliminate the positive charge on the oxygen. As in the case with a hydrohalogenation reaction, we're going to generate the more substituted carbocation, which in this case is this tertiary carbocation. The water, which has a lot of electron density on the oxygen, will attack the carbocation, generating a new bond between the oxygen and the carbon. Notice we have this extra hydrogen atom on our oxygen, which generates a positive charge on the oxygen. This can be removed when we have the sulfuric acid conjugate base. This negative charge here can attack the hydrogen, which will donate its electrons back onto that oxygen and neutralize that negative charge. Notice this also will regenerate our sulfuric acid. That's why we call it a catalyst. It's regenerated in the reaction, it's not used up. The only reagent that is used up in this case is water. Now, because this reaction generates a carbocation, it follows the same basic rules that we talked about with hydrohalogenation reactions. If you want to refresh on these rules, you can go back to the previous presentation, but essentially we're always going to form the Markovnikov or more substituted product. We're going to generate racemic mixtures because we have a planar carbocation, and it is possible that we may have a carbocation rearrangement occurring because we have a carbocation formed as an intermediate. So to summarize, hydration reactions, just like hydrohalogenation reactions, proceed via an electrophilic addition mechanism. We add an HOH across a pi bond. This forms the Markovnikov product as a racemic mixture, and in some cases you can have a carbocation rearrangement.